So let's solve the two-sum problem from Leetcode. And this is a really good problem for those who are starting with Leetcode. Yeah, I'm also learning, so let's learn together. Let's give it a thumbs up. It's really cool problem. So we have an array of integers. We call it numbers, and an integer target, and these are the inputs in our function, right? Nums and target. This is a vector of int, and this is a one integer. And you need to return the indices, so the positions of the two numbers that add up to the target. Two numbers in this num vector will equal the target. You need to find them, and you need to return their position in the nums vector as a new vector, right? So the idea, I think it's quite, the optimal solution here is to. So yeah, if we have, let's say we have, like 2, 7, 11, 15, and the target is 9. So in this scenario, we would add, we need to take each number and we add it to each other number, and we see which one plus which one gives us the target 9, right? So in this case, it's the numbers 2 and 7, and they are at position 0 and 1, right? So the output expected is to 0 and 1. So how do we do this? If we take this example, so let's say we have, we have this input and the target 9, and basically as we traverse this, as we go through this vector, we want to sort of like, find those two numbers. We start with the first one, and we say, okay, 2 plus, let's say 7 was not here because this is too easy. Let's say 7 was the last one. So we're gonna say 2 plus 11. Is that equal to 9? No. Continue. 2 plus 15. Is that equal to 9? No. Continue. 2 plus 7. Is that equal to 9? Yes. Okay, return them. But how do we do this? So one way is to sort of remember them in something. Like sort of the optimal solution here is to make like sort of a map. And a map is like an abstract data structure that has rows of unique keys and their values, right? So you would have, we know that we keep a map of this key and value, and we say, okay, the key would be the number. So in this case, it will be and then we say add, and we say 2 at position 0. Add 11 at position 1. So I'm looking at this example, right? And so on, right? So the idea is that we want to keep adding until we find those numbers. And why do we use this map? Well, it's kind of the optimal solution, because if you keep adding the numbers, you will be able to look up the previous numbers, right? So so as we iterate, so the initial data input in is here, 2, 7, 11, 15. So you have, let's put it like this. Each time we add a number, we look up in the map to see if we have the number that adds up to the value. Before we add this, we look up to a map and we say, is there a number, let's call it blah, that equals the target, which is 9 minus the current number, which is 2. So we know that blah must be a 7. So then blah here is 7. Before we add 2, we say, is 7 in our map already? If yes, return, then the problem is solved. Basically, why? Because you have the position of the number 7. As you keep iterating the nums, you will have the index, the current index. Current index is I don't know, it's gonna be 0, 1, 2, 3, and we have four items in this case, right? And these are the positions of these numbers. So let's actually translate this. Might not make much sense, but let's actually translate this into actual code. So first, we want a map where we store what we have, the numbers we have visited so far, the numbers we have gone through already, right? So let's call it so std map of int and int, and we call it visited. Yeah, and now we just iterate the nums. We will be adding into this visited map constantly every number, but before we add it, we look up if the other necessary number is already there. For int I is 0, I less than nums the size I plus 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 plus. The current index will be I, and the current number will be at nums of I. So we have int current is at nums of I, right? So now that we have this, what we want here is we're going to have some number plus current will equal the target, right? Let's comment this out. But so then we know that, something plus the current will equal the target, but then we can write this as target some number will be target minus current, because we just swap the position on the other side of the equals, right? So now that we have this, we can just say we know that we need to look in we need to ask this question: do we have it in the map already? So we were gonna say found is visited.find visited.find some number, and this is auto. And if it's found, and that is if found does not equal visited.end. If we have found this number, then we have the current and its position, and then we have this number and this position. We have its position because we added it previously in the map, right? So if we find it, then okay, let's create a vector of integers, and let's call it result, and then we say result dot push back the current index is I, and the previous numbers index found that second, right? And no, this is nonsense. We cannot push like this. We cannot push two elements. This is a vector of int. This is not okay. So we need to do two pushes. So result that push back I, and result that push back the value of what we found in this map, right? Because remember, the key is the number itself, and the value is the position, this number from nums, and the value is the position in nums, or index in nums. So this is our map. So when we look like this in the map, then we have like if we found it, then hey, we just have our result. Then we say vector result, and then push, and then we just return result. Okay, so of course, since we return here, the whole thing will end. The whole function will end. The whole program will end. But if we have not found it, then we just keep adding to the map, right? So we're just gonna say map that push. No, there is no map that push. There is a, first of all, the map is not called map; it's called visited. And there is an insert function, key value pair, and the key is the current number, so current, and the the value is its position, right? Index in nums, and index, the current index was I, right? So we have found number 2, and we know that 2 2 plus 7 equals 9, right? So now that we found 2, we make a vector with both positions. So second here refers to the found arrow second refers to the second element in this row, in this entry. The second is the value, right? First would, this is the key, and this is the key, and we're interested in the second, which is the value, right? So this is the whole algorithm. Let's delete this and let's run. Oh, there's an error. No, void function does not return. In all control paths. Because I don't read. Okay, let's just put. Okay, let's move this results here, and let's say here as well, return result. Okay, good. This is the problem to sum. A very important question right now. Because these solutions are not that difficult to find. They're all over the internet. What have we actually learned from this whole code here, like this whole block of code? What did we learn? Let me just decrease the font size here. So what have we learned here? Well, like when you think about Leetcode, you want to create a sort of problem-solving framework, right? Because from each problem that you solve, you want to get some learning that you can apply to further problems along, like in the future, right? So it's not just it doesn't help to just solve this problem. Like you really need to ask yourself, what have I learned today that has extended my problem-solving framework, and so I can solve other problems as well in the future. So in this scenario, what we have learned, I would say we have learned this data structure. And this data structure is called map, right? It's good to use for things that you want to look up. So this data structure is really good to use when you have to, during the algorithm, you need to store stuff to then look it up. I would say this is learning. Of course, if you have found something else in this code that is worth remembering for the future when you solve another similar problem, please write it down in the comments, because we are all learning, and you might see something that I don't. So you might see some other interesting learning, some takeaway that we could, because this is the most important question that we need to ask ourselves. What have we learned from solving this problem that can help us in the future? And in this scenario, it's exactly there's too much sun here. Okay, in this scenario, it's I would say it's the STD map. So yeah, thanks. And I will be posting this as well for Golang. Yeah, and I'll see you next time. Bye.